So 3.4, so we're going to start talking about properties from algebra and then some postulates that we can also use in order to help us soon begin writing proofs, as we'll see in the next two sections. So first, let's review a couple properties that we already learned in algebra. Okay, so reflexive property. Okay, so for any term A is going to equal itself. Symmetric property. If we have two numbers A and B, and they're equal to one another, so A is equal to B, then B will also be equal to A. That is, I can switch the two sides of an equation. You may have also heard this called the commutative property as well. Okay, transitive property. For any three numbers A, B, and C, so if A is equal to B and B is equal to C, then A is equal to C. So basically, we can skip the middle term in that. Okay, then we got a few others. The addition property. So if you've got two numbers, A and B, that are equal to one another, and then you add the same number to both, so we add C to both A and B, then A plus C will still equal B plus C. Okay, adding the same number to two numbers that are already equal will result in two equal sums. Okay, subtraction property. If A is equal to B, then A minus C is equal to B minus C. So you have two numbers that are equal to one another, and then you come over and subtract the same thing from both numbers, the differences will still be equal as well. Multiplication property. So if A is equal to B, then A times C is equal to B times C. If you have two numbers that are equal to one another, and then you multiply them both by the same number, then they will be equal. Division property. If A is equal to B, then A divided by C is equal to B divided by C. So again, two numbers, A and B, that are equal to one another, you divide them both by C, and the quotients will be equal. Okay, then we got three more. Substitution property. So for all numbers A and B, if A equals B, then A may be replaced by B in any equation or expression. And you see the substitution property pop up a whole lot in algebra whenever you are solving for multi-step equations, like if you had 2x plus 7 equals 3. Okay, and then you moved your stuff around, you would eventually find that x is equal to negative 2. So then you could take that x equals negative 2 and plug it back in. And that's where substitution property comes in. Distributive property. For all numbers A, B, and C, A times B plus C in parentheses is equal to AB plus AC. So you just take that A and you would distribute it, and that's how the distributive property would work. And then this last one, combining like terms, okay? So this one is terms with like variables are combined without moving anything across the equal sign. So combining like terms can look similar to the addition and the subtraction property. So here are the differences in whenever we're talking about this. So if we're talking about the addition or subtraction property, we would have 4x plus 7 is equal to 2x, and then I'd want to move that 4x over here, and I'd get 7 is equal to negative 2x, okay? So this would be using the subtraction property, okay? But now if I want to use combine, oops, and I got a piece of tape there, hang on. Combining like terms, that would look instead something like this. If we had 3x plus 7 plus 3 is equal to 10, and then I take this 7 and this 3 and add them together to make 3x plus 10 is equal to 10, then in this case it would be combining like terms. So combining like terms is whenever I'm combining things on the same side of the equal sign. Addition, subtraction, multiplication, division would be we're doing something across the equal sign. So that's 10 properties from algebra that we'll be using when writing our proofs, and then a few other postulates to keep in mind as well whenever we start writing our proofs. Okay, so we've talked about a couple of these back in Unit 1, so we're going to hit them one more time. So 7 postulates that we can assume to be true. Through any 2 points, there is exactly one line. So if you got any 2 points in a plane or anywhere, there's always exactly one line that can go through them. Okay? Number 2, through any 3 points not on the same line, there's exactly one plane. Or another way we could reword this is 3 non-collinear points determine a plane. Okay, number 3, a line contains at least 2 points. So 1 and 3 kind of are related. Okay, so number 1 tells me that if I've got 2 points, there's exactly one line that can go through it. And then number 3 tells me that if I have a line, then I must have at least 2 points on that line. If I've only got 1 point on that line, then it can't be a line. It can only be a point. So for there to be a line to exist, there must be at least 2 points on that line. Okay. Number 4 is related to number 2. So number 4 says a plane contains at least 3 points that are not on the same line. So up here, number 2 told us that basically if we start with 3 non-collinear points, we can create a plane. And number 4 says that if we start with a plane, then we must have 3 non-collinear points as well. So 1 and 3 and 2 and 4 are related. Okay, next up, number 5. If 2 points lie in a plane, then the entire line containing those 2 points lies in that plane. Okay, so again, 2 points, through any 2 points, there's going to be exactly one line. That's what this first one up here tells us. So if we've got 2 points that are in a plane, then that line that contains those 2 points, the entirety of that line is also going to be in that plane as well. Okay, number 6. If 2 lines intersect, then their intersection is exactly 1 point. Okay, so 2 lines, they can only intersect once. Okay, so there's no way you can have 2 lines that would intersect at 2 different spaces without them having to change direction. And thus, if they have to change direction, then you really just drew another line. So 2 lines are intersecting, they can only intersect at exactly 1 point. Okay, and then number 7, if 2 planes are intersecting, then their intersection would be a line. Okay, so imagine if you were to take a sheet of paper and then push it through another sheet of paper. Okay, so that intersection of where those 2 planes would meet would be at a line.